Hi everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at ionisation by radiation. Okay, so today we're going to be looking at ionisation by radiation, and we're going to be answering this question: why is nuclear radiation dangerous? Okay, so there's a few words that you need to know the meaning of during this lesson. So I've mixed up the meanings here to these three words. We've got three keywords: ionisation, irradiation, and contamination. The meanings next to them, the definitions aren't in the correct place. I'm going to let you pause the video, see if you can fix that, and then I'll show you the answers. Okay, so pause it there. Okay, so did you pause it? Did you have a go? Let's have a look at the answers. So, ionisation. You can spell it with an S or a Z. I think probably the English-British way is probably with an S, and then it's changed over time to be with a Z as well. But either way is fine. Ionisation is any process in which atoms become charged. Irradiation is when an object is exposed to ionising radiation. The object does not become radioactive. And contamination is the unwanted presence of materials containing radioactive atoms on other materials. This is due to the decay of the contaminating atoms. Okay, so there's three definitions that you just need to be aware of. You need to know those three, and it will help if you sort of have an idea of what those mean as we go through this topic. Okay, so what is ionisation then? So there's three different examples here of ionisation. Here you can see an alpha particle coming in and stealing some electrons from this magnesium atom. And as it does so, then the magnesium atom has got less electrons than before. So there's an unbalanced number of electrons and protons, so the magnesium ion has become positive. Here, beta minus particle here has come in and it's struck the electron that's going around the outside of this nucleus, so it's knocked an electron out of the orbit, out of its energy shell, and so this atom has become positive because an electron's literally just been knocked out. So again, there's an unbalanced number of protons and electrons, and so this atom has become an ion. It's become a charged particle. It's become positive in this case. And then gamma rays they're not a particle, but gamma rays have got enough energy that they can give energy to electrons, and those electrons then can move around in the energy shells, and sometimes they can even leave the energy shell completely, leave the atom completely, and so then an atom becomes an ion and becomes charged as the electrons leave. So when atoms lose electrons, they become positive. When atoms gain electrons, they become negative. When an atom has an unbalanced number of protons and electrons, it becomes charged and is called an ion. Okay, and here's our three examples again. All of these examples were actually taking electrons away from the atom and making the particle charged up positively. So, we know what an ion is, and we've seen that nuclear radiation has the ability to ionize some things, and alpha, beta, and gamma have got a different ionization ability and the ability to make things into ions. And because of that, it's one of the ways that we can tell that there are different types of nuclear radiation. So if you put some paper, aluminium, and some lead in front of some nuclear radiation, and you're not sure what it is, you can tell what it is by how far it goes through these things, and it's linked to its ionization ability. So you can see that an alpha particle is stopped by paper, a beta particle is stopped by some aluminium, and gamma rays are stopped by lead. And that is all to do with their ionization ability. So alpha particles are easy to stop, gamma rays are hard to stop, and beta particles are somewhere in the middle. And radiation that ionizes atoms easily has a low penetrating power, so it can't penetrate through stuff very easily, and that's because they lose energy each time they ionize an atom. So alpha particles, because they are so good at ionizing other atoms, because they've got a charge of 2+, they get stopped by paper. They also have a very short range in air. Beta particles, because they are 1-, they also can ionize things quite easily. Again, because they're a particle, and as we saw, they sometimes hit into the electrons in the atom and ionize that atom. Gamma rays, because they aren't actually a solid particle, they find it a little bit more difficult to ionize things, but because they've got so much energy they can, but they've got a very long range and it takes quite a thick bit of lead to stop the gamma rays completely. So this is how we found out that there are different types of nuclear radiation by performing an experiment a little bit like this. So what are the dangers of ionisation then? So ionising radiation can be dangerous. Alpha, if ingested, can be more dangerous than beta or gamma because of its ionising ability. So because alpha is stopped by a piece of paper, it's also stopped by the skin on your hand. So actually it's not particularly dangerous normally because alpha would just be stopped by the skin on your hand. It won't actually get into your body. But if that somehow gets into you, if you ingest it, or if it goes near to your eye or something like that, then it can be quite dangerous because it is so strongly ionising. So exposure to radiation can be reduced by keeping a good distance from the radiation source, spending as little time near radiation sources as possible, and shielding behind lead and concrete barriers. This is what happens in hospitals and things like that, where they may use gamma rays or other types of radiation. They will stand in a different room that is lead lined, or maybe got thick concrete, so that the radiation can't get through to them because they're obviously dealing with it every day, and so otherwise their exposure would be quite large. And also, if you do have multiple scans, then you may be advised not to have too many types of too many scans that involve gamma or something like that in a year, so you don't get overexposed to the gamma radiation. So we've looked at one way that we can tell the difference, and to do with their ionisation. We've looked at the dangers of ionisation. There's another way that we can tell the difference between these particles, and that's if we fire them through a magnetic field or an electric field. So if we fired them through a magnetic field, then you might see something like this. So you can see that the large, heavier alpha particles, they move slowly, and they get deflected a slight amount by a magnetic field. Beta particles, they're faster, but they're lighter, so they get deflected a lot. And you can see the gamma rays don't get deflected at all because they aren't a particle and they're not charged up. So because alpha and beta are charged up, they get deflected by the magnetic field. Now, they've got opposite charges, and so they go in different directions when they get deflected. Alpha particles in this case are moving to the left, and beta particles are moving to the right because of that magnetic field that they're going through. So alpha, beta and gamma are deflected by a magnetic field. In this case, it's going into the board, acting perpendicular to the path of the particles. Alpha particles are heavy and so are deflected a little. Beta particles are deflected much more because they're nearly 2,000 times lighter. They have a negative charge while alpha particles are positive, and so they're deflected in the opposite direction. And gamma rays are not deflected at all because they have no charge. Okay, so that's pretty much the end of this one. These are the things that you should be able to do. So you should be able to rank the three types of nuclear radiation in order of their penetrating power and range through air. You should be able to describe how the penetrating powers of radiation can be measured. You should be able to describe the path of nuclear radiation through a magnetic field and describe the process of ionisation. And you should also be able to explain the risks caused by alpha radiation inside and outside the human body. And that's actually where we started, wasn't it? We asked this question: why is nuclear radiation dangerous? So we've talked about the fact that it can ionise things. Now, if that ionises cells or atoms inside cells, so these cells can either be killed off because of the radiation, they absorb the radiation and they just die, or if the DNA inside the cell is mutated, it can change what that cell does, and it could mutate it so that it just reproduces and grows, and that's what a tumour, that's what a cancer cell is, and it just reproduce and reproduce and cause a cancerous tumour. And that's one of the ways that radiation can be dangerous. Okay, so this lesson's been all about ionisation by radiation. I've been Mr. Baker, and I will see you next time.